Yeah.
Hello, guys. Me and Maisie were talking about physics, so Maisie has something to say. Go ahead.
Yeah. So basically, I've been doing some calculations. Hold on. Sorry, just opening my book here
Yeah,
to have a
it's
reference
fine.
point.
It's fine.
So basically, my hypothesis is this. Now, hypothesis, not theory. Okay, keep that in mind.
Yeah.
There are many things to clear up. But I think that basically the geospatial orbit of the simultaneous event horizons is not constant. So if you relate the composition of the masses,
Mm-hmm.
the point of the highest mass relates to the
Uh-huh.
hyperbolic subresonant variations
Uh-huh.
bonded on a quantum level. And that creates a non-constant charge that runs through the extraction point and creates a resistance with the interplanetary orbits,
Okay, I see.
right?
Hold up. Let me write this down, just so I don't forget this. Let me just.
Oh yeah, yeah. Wait, let me edit my notes.
Let me just. Right. You see, I'm liking what I'm hearing. You know, I feel like this is a very elegant explanation from Dr. Maisie. Um,
Mm,
you know.
wow. Oh, don't.
Yeah. Well, I feel like there's one thing that we haven't thought about is actually the quantum field of the geospatial orbit. I mean, of the probe. Sorry, I can't forget about that part, can I? Because if you take the speed of light, right, and if you accelerate at a velocity that the intergalactic thermodynamic atoms move at, then you
mm,
see that quantum
mm,
chromosomes show up. And
mm.
this is where the extraction point comes into play because
Ooh.
you have negative charged
Ah.
recharged electrons, right? And and that causes like an insane change in
Mm.
quantum gravity. I mean, just think of this in your head, all right? Picture a model of the geospatial orbit, right?
Ooh.
Of the probe.
Yes.
Yes.
Mm.
Um
Interwoven at a molecular level. Mm-hmm.
yes, exactly. That's exactly what I was saying. And if you take the waves, the superficial waves of the virtual particles that the geospatial orbit sorry, you can see
Mm.
that it produces an amount of sonic energy that,
Mm.
you know, the mass just, it just, what can I say? It just explodes. It,
Yeah, and we can implement this into the quantum
uh-huh.
field theory.
Yes. Oh my god, wait, you're so right. Oh, Maisie, smart
Mm.
little chud. That's insanely intelligent.
Thank you. Oh, stop.
All right, and also, I'll be running simulations on Smart Scan for this. You know, I do have a PhD in quantum mechanics and
Mm.
like computer
Mm.
computer science and
Mm.
engineering and pretty much everything
Well,
you could think of.
keep it clear for the layman. Keep it
Yeah.
clear for the layman. Mm.
uh, Let me just I can't forget about this, you know. So let me just open my notes here. I mean, oh shit,
Mm.
no,
Mm.
oh, not this book. Sorry. Let me get another one. This is not the
So
book.
so 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 which textbook are you using? Because I'm using uh you know John Graham's edition of Intense Quantum Mechanics Edition 3. It has a gold cover. I'm not sure if you're familiar with this.
I am actually quite familiar with that one. Yes. Um.
Mm. Mm.
Hold
Mm.
up. Let me just. I'm a little thirsty. Let me just.
I think it goes into detail about
Yeah.
plasma field wave phenomena harmonics and
Yes.
the
I do remember
functions
that.
involved.
I do remember that. I remember when I was reading page 125, and I saw that there. In fact, but that is not my main textbook.
Mm.
So what I use actually is the quantum gravity of the sine and cosine waves.
Mm.
By I think think it was. Sorry, I forgot the name.
No, 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 it's the
I'm
Einstein-Globstein
getting a little.
function.
I'm getting a little nervous. Oh, oh yeah, that was the one. Wait, what was it? Epstein? Wait, what was it?
No, 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 Einstein-Globstein.
Oh, right. You I'm a little silly. Sorry. I could have just looked at the cover, but I really didn't do it. Guess I just didn't want to lose the page I was on. I'm currently actually reading about the mechanics of the quantum fields, and that's where I came up with the theory that we're talking about right now.
Wait, wait. Have you heard the Diddy-Bladonics theory?
Did you say Diddy Bladonics?
Yeah.
Yeah, I've actually heard of that one. I mean, it's not like big in science right now, but I did hear
Yeah,
that
it's underground. It talks
it is
about
underground.
the spatial harmony with the waves and,
Yes.
how it relates to the, positron,
Uh huh.
uh, energies.
This could mean something to us, mates, because our theories. There's always gonna be something wrong, and I feel like we could really implement this theory into our own theory, because
Mm,
if
mm,
you
mm,
do look at
mm,
the
mhm.
geospatial orbit of the probe, it does feel like something is missing, and I do feel like it's the sonic energy that we haven't calculated.
Dude,
I mean, there is polarized quantum noise that we haven't thought about in this. Which is pretty important in quantum
oh.
physics itself.
Oh, you're right. Ah, doink! How could I not think of that?
And and that's just the quantum field density of the extraction point. I mean, you just see that
Mm,
they're virtual particles with a hypercharge of 7, and they're harmonized,
mm,
right? They're harmonized,
mm,
and it
mm,
causes just a
mm.
disturbance in the vibrational
Ah, mm.
python.
Yeah. Mm,
Sorry, I got a little nervous there. I mean, I kind of forgot what I was saying because I'm just so caught up in this topic. I mean, there's so much to talk about here.
mm.
It's crazy, right?
Going back to Diddy Bladonics, I think that I need to mention this because I've actually I've been putting things in my calculator. And I was like, what am I doing? Right?
Yeah. Yeah, go on.
What am I doing on this calculator?
Yeah.
Because Diddy Bladonics, God, it's such a big theory. It's such a thing you have to just read and read and read and read until you really understand it because you can't just apply Diddy Bladonics like you don't know what you're talking about, you know? Like what am I doing on this calculator if I don't
Yeah.
know the full, am I some kind of Epstein, to
Yeah.
be
Or
doing
like
this?
Einstein. Are you like some kind of Einstein dude? Because I don't think any of us are Einstein for sure.
Yeah, honestly, I'm getting way ahead of myself and like there's oh god, and there's so many other theories that are interwoven with this, like the Tungtung-Sahorian theory, and god, I have to read up on that as well. Like, I'm busy. I'm busy these days.
Yeah. Yeah. Have you seen the formula for like for the theory of the did he what was it again? Can you remind me?
Diddy Bladonics.
Did Bodonics. Okay, hold up. I swear I saw a formula for something here. Let me just grab my notes. Oh, it's not in this textbook. What am I doing? Hold up. I need to stand up for this one.
Dude, I have like 6 or 7 textbooks on my bed right now.
Yo, okay, so I've got my textbook here where they've actually talked about you know the theory, the Diddy blood con. What was it again?
Diddy Bladonics.
Yeah, exactly.
I mean, what
So
are you even doing on the calculator if you don't know how to say it?
oh, that's a good one, bro. Yeah, and I think they actually made a formula for what we're doing on the calculator. So so we've got this. We got calculator equals quantum fluctuations times relativity, and
Hmm.
it's and you also gotta times that by Heisenberg uncertainty, and
Mm.
the thermal noise you gotta
Mm.
divide all of that
Mm.
by the thermal noise, and
Mm.
then you just need to add you need to add
Mm.
not multiply but add the wave function and the background radiation of the calculator. So
Mm.
and you need
Mhm.
to multiply by that by
Mm.
67
Mm.
grams,
Mm.
which basically says what you're doing on the calculator. But apparently there's a few mistakes in it, like the quantum fluctuations part. It apparently doesn't make that much sense.
Mm.
What do you think about
Mm.
that?
Well, first of all, first question. Well, are you using Tungtung Sahurian units or are you what?
I'm actually using let me see, what was it again? There's a lot in this
Hmm.
topic, right? Let me just
Hmm. Well, one thing I have to point out is the interference analysis of the waves because they're transverse and their frequency wavelength relationship really, God, it hits me in the antinode, right?
right.
Um, yeah, good one, Maze.
I mean,
Mm,
that's a
mm.
top physics joke only PhDers get. Like, come on.
Right. Well, I personally don't have a PhD. I am what some people would consider an amateur.
Oh,
But
oh, but I don't think you're an amateur. You should sign up for a PhD right now. Wow. I
yeah, I
love
should
that.
sign up. I think I saw a poster on the wall in town.
What?
And it just like it said who wants a PhD, who wants to sign up for a PhD program. And I put mine down, and I put my phone number, but when the person called me, they were they were saying such carnal things. Like get a load of this. Oh, I can't even say it on here, but get a load of this PhD, right? But
Ooh.
this person actually said other things and said apparently in certain online spaces, PhD can mean something else.
Yeah.
So, mm, mm,
Well, let me tell you this. I got my PhDs on Reddit. Yep. So I was in this
oh.
science subreddit, right? And I saw this post, who wants a PhD? And I was like, me. And that was pretty much the beginning of the process. I won't talk about the rest because it's kind of, it's not something I can really talk about. It's a little taboo.
Mm,
But
mm,
you might have to go see for yourself. Look, scan Reddit, scan the science subreddits. I mean, I even have a PhD in dream science. Isn't that crazy?
mm,
Like, that's insane.
mm,
I've got all these
mm,
PhDs and I can't really do anything with them
mhm,
because, well,
mm,
they are official, right? But
mm, mm, mm,
it's just
mm,
every
mm,
company, every job wants
mm,
me, and I'm like,
mhm,
ladies,
mm,
calm down, you know.
mm.
kind of like the kind of how
Oh,
like the geospatial
oh,
probe, it just starts
oh, oh,
fluctuating around when there's a bunch of electrons
mm,
around it.
mm, mm.
Good one, right?
Good one, Miriam.
Thank you, thank you.
Mm.
So, would that be the end of our conversation, or do you have anything else to add, Maze?
Well, really, I could go on about this for hours. I mean, we still have to talk about integrating the resonance. Oh, I'm sorry, fractal resonance harmonics, and then we can talk about psychic oxidation, astral travel, using unsubstantiated relativity. I mean, God, the Heisenberg uncertainty theorem that applies heavily here, and obviously it applies in all contexts of quantum mechanics, quantum physics. But I feel like I can make use of it in here in tweaking the model that we currently
Mm-hmm.
have.
Hmm.
Mm.
That could be.
And
That could make
yeah.
sense. Hmm.
Mm, mm.
So, do we leave that for another debate, or do we add um the things you wanted to talk about because I don't mind. I can sit here all day.
No, 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 no. I think that's enough for now, and because I have calculations and smart scans to go back to. God, I mean, my computer, my computer's constantly asking for smart scan. Well, not actually asking because the computer can't ask, but well, technically it can because I actually have this thing I've downloaded. Now, for some reason, it makes my computer slower, but basically, there's this woman standing in the corner of my screen at all times, and she's telling me, "Get back to work, get back to studying," and she like jumps up and down, and it's like, "Get back to
Oh,
work." It's a
yeah.
very big motivator for me because, well, you know, um, and yeah.
Yeah, I mean,
So,
I do actually have something similar over here. I mean, sometimes when I do need the motivation, I put on something called what was it? Hold up. What was it? Let me just I think it was Mommy ASMR. It really helps. It just really helps.
so,
Just hearing all of those motivational words from, this kind woman. It just fills my heart with joy and will to live. I mean, I'm doing this
mm,
all for
mm,
science.
mhm, mm, mm,
Uh-huh.
yeah, yeah.
Okay, is that where we should end?
Yeah, I suppose.
All right. Bye, guys, and see you in another episode.